some differential equations. We've got a substitution. So we've got dy by dx equals that fraction, and we've got to use this substitution with those boundary conditions to get that final equation involving y's and x's. So here we go. Now we need the dy by dx. We use this substitution. So dy by dx, I need to use the product rule because v is a function of x, it told us. So I differentiate the v and multiply by the x, and then differentiate the x and multiply by the v, which will give me just v. So the left hand side here is just x dv over dx. On the right hand side, well, I've got x squared is alright, but I need to eliminate the y's really because I want to solve v and x. So the y is equal to vx, so 3vx all squared. And then x times vx on the bottom, then multiplying it out, I get this, and I can cancel out then these x squareds on the top and the bottom, divide the top and bottom by x squared. So this left hand side x, that original dy by dx, is 1 plus 3v squared over v. Now I'm going to try and separate the variables, but I need to get the v's into one fraction. So I'll stick the v on the other side, put it in the fraction with the 1 plus 3v squared, and it becomes v minus v squared there. So it's 1 plus 2v squared over v. And this is sort of the differential equation between v and x that I'm going to solve first. Now I can separate the variables, so I get the v's on one side and the x on the other. I'll stick the dx up here. Then I need to sort this fraction out, so the v is going to go up here, and the 1 plus 2v squared is going to go down here, and then I'll divide both sides by x as well, so I have 1 over x. And then stick an integration sign in front, because that's what I'm going to do to get rid of the dx and the dv's. But if I differentiate the ln of 1 plus 2v squared, I get 4v over 1 plus 2v squared because of the chain rule. So if I put a quarter in front, I'll put a 4 on top there, and then I've got ln 1 plus 2v squared differentiated. So then integrate both sides. The left hand side will be a quarter ln 1 plus 2v squared. The right hand side is be ln x. But I need to put a constant of integration in because I'm integrating. You don't need to put it on both sides, just on one side. But I can write this as the ln of a times x because the c is just a constant. So it's going to be the ln of a constant as well. That a really is just e to the power of c. But it's just some number that I'm going to find out what it is later when I use these boundary conditions. But I'd like to get rid of the ln's. So I'm going to multiply both sides by 4. And then this right hand side then I can write as ln of ax to the power of 4, and now I've got an ln equals ln, so I'll get rid of the ln's now. So 1 plus 2v squared is ax to the power of 4, but again I've got this a to the power of 4 is just a constant, so I can write as b x to the power of 4, that right hand side. Then I'm changing my v's into y's over x's, the v and y over x, because I want an equation in y's and x's. If I multiply through by x squared, I get x squared, and then 2y squared is bx to the 4. And now that's about as simple as it's going to get. So now I'm going to make my substitution using those boundary conditions. X is 1, so 1 squared, and then 2 lots of 1 over root 2 squared is another just 1, and then the right hand side is just b, because it's b times 1. So the b is equal to 2. I can put this into here, and then write it the way they wanted it. Divided by 2 and stick in the half x squared on the other side.